Okay, now let's put the last wire on, the white wire. Make sure you're in camera, yep. There we go. Okay, that's the white one. Now we will just pass the cable through the cable tie. And now all the cables in the cable tie, we can pull it tight. And they're lock solid. A little bit more. Make sure it's nice and tight. I shall put some glue over them and liquid weld over them anyway. Sorry, let's pull you out a bit, shall we? There we go. We'll put some liquid weld over the cables and onto the board just to give it that little bit of extra security. Okay, so there we have it. And the other thing I've got to do is, I'll get my pointer, I'm going to pop the Dremel across those tracks there and across the tracks there, and then that will isolate the whole of the sensor. In the next video I've got a piece of linear encoder ribbon from a printer. I don't know if you can see that very well there, but that's what we'll be using to test the action of the sensor, and we'll show it on the scope. Okay, so that will do for the wiring up, and as I said, we'll power it up on the next video and do some simple scope tests, and then we're ready to install it back in the white table and put the white table back together. Right, there we go, people. Okay, here's the encoder. This is the yellow wire. That's one of the outputs. As you can see, if I move it very slowly, it's not very compact. When I move it quite quickly, I don't keep it in the slot, of course. Move it quite quickly, and they're a lot closer together, and further and further apart as I slow right down. There we go. So there's a signal out of one wire, and here is the signal from the other wire. And again, if I slow right down, further apart, if I speed up, they get closer together. So there we are, it works. And it's only 5 volts I'm putting in, so it is a 5 volt system. Now I'll go on to what I discovered when I started to test this. Excuse me. Okay, now this is what I've worked out for myself. I haven't got this from any data sheets or anything. I've mimicked the way the pins are on the printed circuit board and drawn in how it's wired to give me the outputs that I saw. In the previous videos I was calling the two center pins the sensor outputs. That was wrong. In fact, the output is on the outer pin of the group of 4 and the second pin in on the group of 4. So this is how I've got it wired up. The red 5 volts is coming into the resistor, through the resistor to the photodiode to earth, and ground is the green wire. Now here's the red wire into the resistor, into the photodiode, and common to green with output to sensor. I suspect, I do not know again, I just suspect that these are phototransistors, one's NPN and one's PNP. I suspect the one on the positive line is the PNP and the one on the negative line is the NPN. I may be wrong, someone will point me in the right direction, but anyway, as you saw on the scope previously, as I ran the plastic encoder through the sensor, we got signals out on the white wire and the yellow wire, okay, with green being negative and the orange being plus 5 volts. And this is the linear encoder sensor for the y-axis. Now on the x-axis I've got a rotary encoder, which is totally different. It's only got 4 pins. So I suspect that's just a straight photodiode, phototransistor, or another photodiode. I don't know. Again, there's no numbers on it or anything like that. But I'm only wiring these for later use if required. When they're required, then I'll do the research and look into it more deeply as to how to go about wiring them up and everything. Okay then.